Tired of mail-in votes for elections? Why don't you get out of your cave and vote with high-tech quality goodness? Introducing electronic voting with super fobs. In this state-of-the-art voting system, all the fobs work together to first determine a poll leader, responsible for both receiving and sending those votes to a Raspberry Pi server. The poll leader is determined using a Boolean algorithm, where the fob with the lowest device ID is selected for that position. Here is the finite state machine for selecting the poll leader. Each circle represents the state of the given fob, where it can either be a candidate, a poll leader, or a non-leader citizen. Now these states change based on timer events, where there are 3 timeout flags known as election timeout, leader timeout, and leader heartbeat. These 3 flags mark the conclusion of an election, leader term, and leader heartbeat, respectively. Let's take a look at some possible voter graphs in our web interface. Lovely, isn't it? Let's see what Jonathan has to say about the kind of security problems that may arise in our voting system.
You could DOS attack it by sending lots of garbage to the Raspberry Pi server. You could influence the vote by sending valid votes to the Raspberry Pi server. You could influence the vote by sending UART. It's valid votes over the UART. You could do a man-in-the-middle attack on it between the Pi and the poll leader. And then finally, you could attack the database itself.
Well, at least we got 3 meters of range with IR, right, Ryan?
I swear I can see it. It's that 3-meter range. It's in between them trees out there, I swear. We're never gonna get it, are we, though?
Few issues we had were that the fobs were only able to communicate over IR up to about a foot range. And while they were able to elect poll leaders over multiple local networks, the votes were not able to be passed through those local networks.